Lesson, and it is the last lesson of this chapter, is going to be in forces and friction. And then we're going to do some practice at the end with weight and free-falling objects from Tuesday. So the definition of force is something that can change the state of rest or the motion of an object. So I want you to think about a chair in the middle of my room. If there's no force placed upon it, it just kind of stays where it's at. Okay, that goes back to Newton's first law that an object at rest is going to stay at rest unless something acts upon it. When you push that chair, if you let go, another force, the friction from the floor and also a little bit of air resistance, is going to stop that chair from moving. So a force is anything that can change the state of rest or the motion of an object. So get it moving or stop it. You should highlight that definition. Balanced forces is when you have opposite forces giving an equal change, so there's no movement. A really good example of that is an equal tug of war. An unbalanced is going to be exactly the opposite, when there's a larger or smaller force on one side that causes movement. Another example is a team losing in a tug of war. And I would actually highlight this whole slide. There's 3 questions on your test and your term about these. Friction is the force between 2 objects in contact that opposes the motion of those objects. So I mentioned that in the first slide. When I push that chair across the room, eventually it stops because the floor is pushing up on it. There's also a little bit of air resistance that we'll talk about a little bit later. These are 3 other kind of definitions to friction. I would highlight the first one right after the equal sign. It's caused by 2 objects rubbing against one another, trying to slow down or stop an object. There's 4 different types of friction. The first one is static friction. This is the friction that is needed to be overcome to start an object moving. What that means is the chair in the middle of my room, static friction is holding it in place. Okay, I have to overcome static friction when I push it to get it to move. So basically it is the friction happening with a standstill object. Sliding friction is the friction of a moving object, one object rubbing against another. So as soon as I push that chair, as it slides across the floor, that would be sliding friction. Another example of this is when a car puts on its brakes very, very quickly. Okay, you have maybe some skid marks if it was going really, really fast. That would be another example of sliding friction. Rolling friction is the friction of a moving object on a round or rolling object. This would be any sort of car when it's moving, not when it's trying to stop, but when it's actually moving down the road. A toy car, anything that has wheels is generally a really good example of rolling friction. The last one is called fluid friction, also maybe air resistance or drag force. This is the resistance of an object moving through a gas or a liquid. Some really good examples of that are a plane through air with some air resistance, or a boat through water. That water's kind of pushing back on that boat to keep it from moving. Just a reminder about gravity. That's the force of attraction between 2 particles of matter due to their masses. And just remember, every object is attracted to every other object, except it depends on the mass or the size of the object. So like I said earlier in a lecture, we stay on Earth because of the force of gravity from Earth is so big because its mass is so big compared to our small mass. So, and this just talks student to student. There's not much student to Earth, Earth to Sun. Okay, it just depends on the mass of those objects, how much gravity is pulling. What I want you guys to do now is get out the notes that went along with Newton's laws. I think we did these on Tuesday, and go ahead and flip to this slide. So go ahead and pause the video while you get those notes out. We're going to do a little bit of review because you're going to practice the math that went along with this lesson. So pause the video, get out these notes, and then you also need a blank sheet of paper if you want to get those out too. Here's a couple of reminders as you get ready to do the practice problems from this lesson. The first equation was weight equals mass times gravity. I never actually had you draw a triangle, I don't think, for this, but you would put weight on top and mass and gravity would be on the bottom. Reminders that weight is measured in newtons, mass is always in kilograms, and gravity is always 9.8 meters per second squared. Remember, that's a number that you have to know. All right, so if you see any practice problems that say, what is the weight of a puppy? What is the weight of an object? This is the equation that you would use. So if I pop to some of the problems from today, as it takes a hot second to load. This first one here says, what is the weight of an object with a mass of 3.2 kilograms? So you would take this 3.2 times gravity, which is 9.8, to get your answer in newtons. Moving on to the next equation. We did do a triangle for this one. This is the velocity or speed of a free-falling object. So this is one that you drop off the top of a building or you drop from a desk when you're standing or something like that. Remember, velocity equals gravity times time. Remember, G and A are the same thing. It's the force due to gravity, which is 9.8 meters per second squared. So an example of this type of problem would be number 2. It says a lead weight is dropped from the tower. It takes 7.3 seconds to reach the ground. What is its velocity when it reaches the ground? All right, so remember, velocity is gravity times time. It only gives you one number. It gives you the time, which is 7.3. And you're going to take that times gravity, which is 9.8 meters per second squared. The last one I want to go over real quick is this guy right here. We're looking for a distance. They could also use the term height. If you're looking for the height of a building, if you're looking for the distance an object fell, you're going to use this formula right here. Remember, acceleration is gravity, t is time, and you're going to always square that first, and then you're going to divide by 2 after you multiply the top. All right, so this would be an example of one of these guys. If we look here, number 3 says an object at rest is dropped from a high building. If you dropped the object off the building, it took 4.5 seconds for the object to hit the ground. Find the height of the building. They're asking you to find distance with the height of the building. So if we go back to this formula here, we know that A equals 9.8 meters per second squared. The T, if I go back here, the T is 4.5. So what you would do is you would take 4.5 times 4.5, multiply that times 9.8, press equals, and then divide by 2 to find out how many meters that building is tall. So that should cover this worksheet right here. The other worksheet you guys are going to have posted to Classroom is going to look like this, and it's a complete mixture review of velocity, of acceleration, of free fall, excuse me, of distance. So it's going to be all sorts of practice just to review these problems. Okay, this chapter is much full of math, and it's very important that we know how to do all of these for the test if we do test over this chapter, but definitely for the term assessment when you guys will see these. So that's your homework, I guess. This lecture isn't super long, so you should be able to get through a lot of it during class. I am, like I said, hoping to be back tomorrow. I will know more this morning, which would be Thursday morning. So by the time you guys watch this, I will know whether or not I will be back Friday or not. And once I get back, we will take this all, we'll review it all. I'll help you with the math, and we'll be good to go. We'll be solid, I promise. So have a good rest of your day.